Pythagorean theory. Right? So we know that everybody knows the Pythagorean theory, okay? If it's triangle and a squared plus b squared equals c squared, and if the complete statement is triangle is a rectangle if and only if the right triangle if only a squared equals b squared, a squared plus b squared equals c squared. Okay, so it is right triangle if and only if a squared plus b squared equals c squared. That's a complete statement. In other words, if the three sides satisfy this equation, a squared plus b squared equals c squared, this must be a right triangle. Right. So, okay, so the theorem itself is very simple. So we are going to do the following problem. The first problem we're going to study is I have a pyramid. I have a right triangle. This is a right triangle. I know the pyramid is going to be 220. I know the area is going to be 990. Okay? Find the length of the so-called hypotenuse. Okay, which is C. And if we label them A, B, C, then you have to find the C. All right. So look at this. You have three variables here, A, B, C. Okay, and you have to write down all the given informations. How many different information given? It's a right triangle. It is given the pyramid, given the area. So the pyramid says that A plus B plus C equals 220. The area formula is half AB equals 990. You only have two equations right now, right? Three unknowns. You're not able to determine the three variables unless you are given another information. All the lengths must be integer. That's another hidden equation. But here we do not assume A, B, C are integers. Instead we assume that it's a right triangle. So a right triangle means there is another equation you must have. So this becomes an algebraic problem, okay? And how to find the C. So this is not a geometry one. It's just an algebra problem. Three questions. You don't need to find the A and the B. You just need to find the C. But sometimes you have to find A, B first. Okay? But sometimes you don't need it. Okay? Just find the C. Okay? Okay, we have to start with them, right? You know, I want to get a single equation in C. Then I'm able to solve it. Okay, use some kind of substitution. But there's no way I can substitute. Okay. The most important formula in algebra here in elementary algebra is A plus B equals A squared plus B squared plus 2AB. Okay? I need that to set up equation in C. Okay, this is my hint. Okay, so look at this. I can put those three equations into the following one equation, and then I get equation in C. How do I do that? So A plus B, I use the first equation. It's 220 minus C. Okay, A squared plus B squared is C squared. And the 2AB, okay, 2AB is going to be, 2 times AB is also 2 times 990, okay? Right? AB is going to be 2 times 990. So 2AB is 2 times 990. Then, the rest of them is trivial. Okay? You just need to solve this equation. This looks like a quadratic equation. Actually, it's not a quadratic equation even. Right? Yeah. So you have to use this identity, the trivial identity. So it's 220 squared minus 2 times 220C plus c squared equals c squared plus 2 times 2 times 990. And c, this is canceled out. Okay? So what I get here is 220 squared minus 2 times 2 times 999 and equals 2 times 220c. And let me to write down the number. Okay? So you just use a calculator, whatever you can do. I give his answer is 101. Okay? So this is the answer. Okay? It's integer. Yeah, it is integer. I'm not sure AB. Can you find the AB? If you know the C, you should be able to find the AB. Okay? Because a squared plus b squared is given, a times b is given, so a plus b is given. It can be solved. Okay? And yeah, you should be able to find the a and the b. They are, maybe they're not integers, I don't know, but we are just need to find the third side. All right, so this is actually then an algebraic question, algebraic problem. We convert the geometry problem to an algebraic problem. Okay, most of the problems in geometry here we study in the United States, we are not going to prove the two angles are equal, blah, blah, blah. We actually use the theorem, but in the procedure, maybe you have to prove something are equal. Okay, but our goal is always to do the computation to find the area, to find the length, or find the location of the point. Okay, we're not going to prove something they're equal. Okay, so the next problem, for example, I have this is a square. Okay, let's do this. Doesn't matter which is square now. And we have a rectangle. Okay, so rectangle. Here's this side is 8. Let's see now. This is a typical piece of board. Okay, 4 and 8. Okay. Yeah, this is a 4 feet by 8 feet. Okay, so I want to find a point such that the distance to this side top is the same as those two. So I mark it X, X, and X. So find X. Okay, so this is a 4 feet, 8 feet. This is a typical size of a construction material. And you want to find a point somewhere, so it's have a say equal distance to all the three, to the two vertices and the one side, north, the side on the top. So you have to find the X. This is where you apply mathematics to do that, right? So you measure it and find the point. So you have to do calculation before you make a hole in somewhere. Okay. So when you give them a geometric problems, don't just sit there. Trying to extend some lines or connect some important points. In this case, all the important points are connected. I think we should extend this line. Once you extend this line, you get right triangles. Okay, you get right triangles. Then you can apply the Pythagorean theory to set up equation in X. So you have to express each side of the right triangle in terms of X. This is already X, right? And the other side is 2, right? Because half a half. Okay? Then you have to express the third side in terms of X. Don't use a Pythagorean theory to find X, okay? We're going to apply the Pythagorean theory later. So you have to express the third side in terms of X. And you look at the picture. From top to the bottom is 8, right? And you subtract the X. You will get this side, right? Now here it's 8. Now from here to here is 8. So 8 minus X is going to be this side. Then you can apply the Pythagorean theory to this right triangle. And you get 2x squared, 8 minus x squared equals x squared. Then x can be uniquely determined because this is a quadratic equation. Okay, so it's gonna be 4 plus, right, 64 minus 16x plus x squared equals x squared, and x squared is gone. Actually, it's not a quadratic equation. Okay? Okay? So that means 16x equals 68, and x is going to be 68 divided by 16. Okay? You can divide by 4, I think. 64 divided by 4 is I think 17, I think, right? Yeah, 17 on 4. Yeah, 17, and that is 4. Okay, so this is a fraction. It's not going to be integer. Then you estimate this number, then you can use the ruler to find the point in the middle, then you make a hole, and that one have an equal distance to all the points. Okay? Yeah, this is it's a very good problem. It was from a similar problem, okay, from a mass count. Okay. Yeah, there are other. Let's see if we have any other. Yeah, sometimes it's a square. It's not necessarily like this side, but this idea is very similar. Okay, there will be quite. So my next problem is, here's a rectangle, okay? A rectangle. This time I'm going to ask you to do that, okay? And the so let's label it A, B, C, D, and I have a triangle inside, okay? And E. What I know, this is a right triangle. Here's a 90 degree, okay? I also have the following information. EC is going to be 2, okay? BE is going to be 8. Okay, this is 8, that's 2. Great. Can you find out AB? Okay? Or sometimes we ask you to find the area of this rectangle. If you find the area of the rectangle, you need to find the other side. So find this X. Right? So because the right triangle sitting there, so it controls the dimension of the rectangle. You probably don't need to draw additional lines here. There are already plenty of right triangles inside. The question is how to apply the Pythagorean theory to set up equation in X. Then you solve the problem. Okay. You may not able to write down one single equation at the very beginning. Okay, my hint is I'm going to call this one as A and that is a B. And C is going to be 10 because 8 plus 10. That's my hint, okay? And trying to find the equations to solve the problem. They write down all the possible equations from the Pythagorean theory. That's my suggestion. Okay? Then it becomes the algebraic problems. Write down 3 equations using the Pythagorean theory. Okay? Then you try to solve for X. and eliminate some variables, just like what I did for the last part. Yeah, Karen, what is that? What is the answer? Okay. Okay, I'm going to show you two different ways to solve, okay? The standard way is to use the Pythagorean theory. Okay, write down all the possible equations, okay? So x squared plus a squared equals a squared, right? That's the triangle on the left-hand side. Then the triangle on the right-hand side would be x squared plus 2 squared equals b squared. Then I know I have to use the information here, the triangle, right, inside the rectangle. So a squared plus b squared equals 10 squared. That's it. And then equation 1, equation 2, right? So equation 1 plus equation 2 will be x squared plus a squared and x squared plus 2 squared. Then you have a squared plus b squared, which should be 10 squared, right? And using the third equation. So 2x squared plus 64 plus 4 equals 100. Okay? And then 2x squared equals 68, 32. So x squared equals 16 and x equals 4. Great. So that's a good idea to solve the problem. Okay? There's another way to do without using the Pythagorean theory, okay? Use a similarity triangle, okay? Here's A, here's 2, this is X, okay? And let me write down, draw the picture again. All those three triangles, right triangles are similar, okay? And my claim is 3 right triangles are similar. Did you see that? A similar means, you know, they are the corresponding angle the same. Think about that. If this is alpha, right? So then this will be 90 degree minus alpha, okay? So 90 degree minus alpha. Let's call it beta, okay? Beta is gonna be 90 degree minus alpha. It's completely determined by alpha, okay? Then this is a 90 degree minus alpha, right? Minus alpha, so it's beta. If this is beta, this is alpha, right? If this is alpha, this must be beta. Then this must be alpha. And alpha plus beta is 90 degree and plus 90. So all these triangles are similar. Then yeah, it's great. You know, all three triangles similar. They can use any of those two to compare. Okay. So look at this. Those two triangles, I'm going to call it. Those two triangles are similar. These two triangles. This triangle and the other triangle, they are similar, right? The corresponding sides, the ratio of corresponding sides will be x over 8. Those two sides compare, right? And then it equals to 2 over x. Those two sides compare, okay? So x squared equals 16, x equals 4. That's great. It's much quicker way to solve the problem. This is a good example. You can have a more, you know, in the geometry can have a more, some geometry will have a multiple ways to solve. Okay, so the next problem looks similar, but at quite different ideas. Okay, let's do the next problem. It's still rectangle. Right? I write that this A, this is a B, this is X, and this is a C. Okay. So I'm going to, what am I going to do? in this triangle, okay, we have this is right triangle, okay? This is right triangle. And here's a, yeah, I'm going to give you the number. Yeah, let me give you a special number, okay? This is right triangle. I just assume that this is a 4, that's a 3, that's a 5, okay? No. No, that's not a good problem. Yeah, I want you to find the x. Okay. Yeah, find x. Yeah, sometimes you are told this is a right triangle. Sometimes you're given the 3 sides like A, B, C. It's clearly this is a right triangle. So we want to get the x side, and then you can tell the area of the rectangle, right? But the most important part is the x. All right, what are you going to do? Any of you find it? We just used the knowledge in the last class. Couple. how do you get x? Michelle Ding. No? Helen? No? Brian? No. Edward says 12/5. Edward is the youngest boy, okay, in this class. Edward Chen. Yeah, he's only, I think he's only 5th grade yet. He's already found it. All right, so let's do it. So this x is the height of this right triangle. Very simple, right? The area of the triangle is going to be half of this is going to be 6, right? Then this also equals to half of x times 5. Got it? So use the area, you can find the x quickly. Okay, which is going to be x is going to be 12/5. Oh, Edward is only 4th grade. Sorry, he said he corrected my mistake. Okay. So 12/5. Sorry, I forgot. Yeah. Yes. So this is x. Then see, do not always think about using Pythagorean. You can use a Pythagorean theory to find this x. Okay, without using the area. So let's do this. Okay, a little bit complicated. So if you have it's nothing to do with the right triangle. This is x. That's a 4 and a 3, right? And let's call this one. I call the y and the z. Okay. Yeah. Okay, so look at this, and just want to use a Pythagorean theorem whether you can solve it. So you have 3 sides, right? Then y plus z equals 5, right? Clear. That's the first equation. Then you have a x squared plus y squared equals 4 squared. Okay? Then you have x squared plus z squared equals 3 squared. So you apply the Pythagorean theory to solve the problem. But you have to introduce as the 2 variables, you are going to have 2 right triangles there, and apply the Pythagorean theory to this right triangle. Then you have to find a way to solve it, right? And looks, it's wise. You see, equation 1, equation 2, equation 3. I think you have to use equation 2 minus equation 3. So x will be gone. Y squared minus z squared equals 4 squared minus 3 squared. Okay, but that's good enough. Why? Because y squared minus z squared is going to be y minus z. Y plus z equals 3 squared minus 4 squared. And y plus z is a 5. So y minus z, this is a 5 by the first equation, right? So y minus z is a 4 squared minus 3 squared over 5. So now you have those 2 equations. Then you find the y and find the z. Then you can get x. So you have to find the y and the z first. It's more complicated, but that's the way you can, without using the area. This is the only way you can do. Okay. So you add them together. 2y equals 4 squared minus 3 squared over 5 plus 5. So your answer is 4 squared minus 3 squared plus 5 squared over 5. I did not multiply them out for some reason. Maybe I should multiply this out. Okay, 3 squared. So you get a y. Okay, then you can get x. Okay, x is, I think, just the interchange 3 and 4 in this case. So x is going to be 3 squared minus 4 squared plus 5 squared, 2 times 5. Plug them, z, okay, z. So add them together, you get 5, and then using y and z can get x by the Pythagorean theory. Okay, so what is how to get x here? X squared plus y squared equals 4 squared. So x squared plus y squared equals 4 squared. So from here, 4 squared minus y squared, and you can solve the problem. Okay. Okay, so you can get x. But the computation is complicated, right? Because the area, using the area formula is best. You can quickly solve the problem. So let's simplify this here a little bit. 5 squared is going to be 4 squared plus 3 squared. And then 3 squared cancelled out. Actually get 4 squared over 5. And similarly, this will be 3 squared over 5. Okay? So now, using that, you get 5 squared is 4 squared and square. Okay? So I'm going to get 4 squared minus 4 squared over 5 squared. I'm trying to, as you can see that I'm not going to, I take 4 square out. I take actually 4 square, 5 square out. What I get is 5 square minus 4 square, which is 4 square over 5 square, and 3 square. Okay? Then x is going to be 4 times 3 over 5, which is 12 over 5. See, very complicated going through. Okay? So let's, this is not the best way to solve the problem. But you can use the Pythagorean theory to solve the problem. Okay, so let's look at the next one. This is going to be square. Okay, and E is the middle point. Middle point, okay? And I'm going to draw, here's F. Okay, what I have here is EF equals FC. So here's A, B, C, D. So that means these two sides are equal, okay? So can you find, this is unit square. Let's assume unit square. Find the area of the triangle. Yeah, so this is a triangle. Now when you look at this triangle, what do you have to find out? First, in order to find the area of the triangle, right, you just need to find the base and the height. The height of the triangle is 1/2. Okay, if you view this one as a base, so this is called the x, right? So the area is going to be half of the base times the height. So it's x over 4. All you have to do is just find the x, right? So this, if you draw the line here, you know, this is only going to be 1/2. This is the height. So that's my hint. So please find the x, right? Using the Pythagorean theory. Write down the equation in x. Sophia? So you get square root of, no, this is going to be a fraction, I think. It's not going to be, yeah, you will get a quadratic equation, but x will be canceled out. So it's gonna still get a linear equation in x. Charleston says 1/4. That is also wrong. 1/4 is just 1/4. Think about that. Use common sense. Look at the picture. X is definitely longer than 1/2, right? Clear. X must be greater than 1/2 because this is just a, the slide, right? The base EB is already 1/2. X is larger than 1/2. Helen, no, but you understand why when I show you how to do it, right? Just it's harder to get it by yourself. That's a geometry. It's different from algebra. The geometry that once you get in, it's easy, right? When you see that, okay. But this problem you don't need to draw addition lines. The key point is you can step 1 draw addition lines if possible, but there's no addition line you can draw it. I just only draw the one vertical line. Okay. Second step is to find the right triangle. You probably can apply the Pythagorean theory there. When you find the right triangle, express each side in terms of x. I just want you to find x. 5, 8. 5, 8. Eric, I was saying, I already said that it cannot be less than 1/2. Now you gave me 1/8. Yeah, I see Edward got answer. Okay, I'm very happy to do that. 8 is the x value. Okay, yes, Karen. Yeah, good. So what we did is we're going to look at this triangle, the EBF. Okay, so this side is the x, this side is 1/2. The other side is 1 minus x. It's a very similar to the one we did before. Okay, why it's 1/x? Because it's a unit square. If I change this to a rectangle, then it would be a different number. Okay, it's a unit square. So 1/2 square plus 1 minus x square equals x square. And that's the important equation. So when you do the homework, I do want you see a picture, and I want you write down something like what I did here. Okay, you draw the triangle, right triangle. You don't need to draw this right triangle here, but at least you have to mark it. You know which right triangle you are consider, and you write down names of variable. Right, write down the equation. Don't just give me the picture and the answer. I want to see your work. It's very important. Very important to learn how to show your ideas clearly, step by step. But keep telling yourself, whatever you put there, ask yourself, can my classmate understand what I'm doing here? If the answer is wrong, if the answer is no, then put more details. Okay, that's a guideline, you know. Otherwise, you say, I don't know how much I should put there, right? So you write down the proof, the solution, and you hand up to maybe your father, right? Let him to see whether he can understand. He said, I only see the answer. How did you do that, right? That means you did not put enough details. All right, so this is the equation. You don't need to, you know, sometimes you have to say, applying the Pythagorean theorem to this triangle. But here, probably this part should be skipped. Then, but at least you have to write down the equation. Then the quarter plus 1 minus 2x plus x squared equals. You still have to write down this equation, and you cancel it, right? Then what do we get here? It's 1. Oh, sorry, it's 1. Okay. Yeah, 1/4. Yeah, make sure this is correct. Okay, so it's going to be this is going to be 5/4 equals 2x. X is going to be 5/8. And you look at the picture. Yes, it's a reasonable 5/8. Okay. Yeah. Now there are some problems. Maybe not rectangle. Maybe when you take a mass count. Okay, so the picture here is a 4, and this is 8, and you're trying to and here's the middle point. It's very similar. And what you're doing here is this x equals that x. You find the errors is trying, and the very similar ideas. Okay, and this is here's E, you know, A, B, C, D, and EF, right? EF equals FC, and you find the X, right? Then the only difference here is this side is going to be 8 minus X. This side will be 2. Okay? So the equation will be 2 squared plus 8 minus X equals X squared. Okay? The idea is similar. So I'm not going to complete this problem. Right, so my next problem is still a rectangle, and this is going to be, right, and A, B, C, D, and I have a triangle there. right? E, F, C. So what we have here is that we are given some information. This rectangle EBC is congruent to EFC. Oh, triangle EBC is congruent to the triangle EFC. Right? So EFC means at least BC equal EB equals EF. Okay, and the BC equals FC. So you just fold the paper, all right, so that this point touch to that point. That's it, right? So that's why you get identical triangle. Now we are given the information. AE is going to be, for example, make it easier, just say 3. Okay, AF equals 4. Okay, and my question is, find the dimension ABC. Find the dimensions of ABC. A, B, C, D. Okay, so I want to figure out the side of this rectangle. In other words, I have to find the BC and find the DC. Okay, what I have here is, this is a 3, this is a 4. Use that corner can determine the group picture, in other words. Okay, what is unknown here is this side is a Y, this side is X. You know, to find the X and the Y. Yeah, we design a piece of paper so that I can fold at the point E, then the point B will touch the other side AD. Okay. So the question is, what is X and Y? What are the X and Y? So clearly, this time you have to write down a couple equations. You have 2 unknowns, right? Yeah, this is a rectangle. Oh, Edward already gave me the answer. X equals 5. I mean, X equals 8.
Yeah, X is 8.
Okay. Yeah, but I have to find the Y, right? Yeah. So the reason X equals 8 is EF equals 5. Okay? Because this is the right special right triangle. And the EF is going to be EB. So X is going to be 3 plus 5, which is 8. Okay? X is going to be AB, right? So AB is these 2 triangles are identical. Those 2 triangles are identical. You just fold it. So EF, if you know EF, you can get EB. So the question is, you still have to find the Y. Apply the Pythagorean theorem. which right triangle you're going to use? Right? Several right triangles there. 1, 2, 3. The other one, 3, 4, 5, you already use it. Don't need it. You have 3 right triangles. So Edward says y equals 12. Okay, let's see. Which right triangle you can use? I think we should use this triangle. F, D, and C. Why? X is already known, it's 8. How about FD? FD is y minus 4. Okay? And this side must be y. That's it. Why this side minus y? Because these two sides are equal, right? And this is going to be, look at this, it's going to be y minus 4. So express each side in terms of y. Find the right triangle. Express each side in terms of y. Then you can you can solve the problem. Right? So I cannot use those two congruent triangles because I don't know what is E and C. After I find the y, I can find the EC. I cannot express EC in terms of y. Okay? So now you apply the Pythagorean theory. Y minus 4 squared equal plus 8 squared equals y squared. And that means y squared minus 8y plus 16. 8 squared equals y squared and cancelled out. And my y equals 16 plus 8 squared. How did I do that? 6 plus 8. That's 12 or not? Hold on. Let me double check my computation. Hi. Did I? Hold on. 5 plus 3 is 8. Yeah. X is 8. Okay. And this is going to be 10 instead of 12. Yeah. Okay, it's 10. So I'm confused. Yeah. All right, it's 10. Good. So Edward, you did a computation mistakes, right? Yeah, this is 10. Yeah. So 16 over 8 is 2, and the 8 squared over 8 is 8. That's why it's 10. So this is the way we solve the problem. Do you see? You have to find the right triangle and express each side in terms of the unknown. Okay. Then you apply the Pythagorean theory. The idea is simple, but you have to find the right triangle. Now our next problem is going to be the following. Okay, it's still similar. In the following triangle, this is a square. Okay, unit square. Let's call unit square. Okay. Oh, we even don't know the it's not unit square. We don't know the square, the size of square, just a square. Okay, and I have still have a triangle here, but this triangle is not congruent to the other one. But this is the right triangle. Okay, A, B, C, D, and this is E and F. I know AE is still equal to 3, and AF equals to 4, okay? Yeah. Can you determine the area of the nothing else, right? Yeah. Find the area of the square. But this is slightly different from above one. We know it's a square. It's not a rectangle. But what we don't know is, we lose another information, which is, the two triangles are congruent. I did not use that part. Okay, I just have a square and I draw a right triangle inside, and this side is 3, this side is 4. So all you have to do is to find the edge length, x. Okay, in other words, find x. That's enough. Okay. My hint is you have to apply the Pythagorean theory to 3 different right triangles. How many right triangles are there? 1, 2, 3, 4. The other one is already special triangle, 3 and 4. So maybe this side is 5. So let's put this, right? So total you have 4 right triangles. And express, yeah, you have to need those right triangles to find the equation for x. I should give you a hint. I called this one is A, that's one C. How about like that? We don't know these 2 sides. The rest of them is fine. Okay. Write down as many equations as possible using the Pythagorean theory, and then you can find x. No? Okay. So let me redraw the picture. I don't want to destroy the original one. Okay, this is a x. Here's A, here's C, right? X. This side is 3, this side is x minus 3. This side will be x minus 4, right? So let's apply the Pythagorean theory. X minus 4 squared plus x squared equals a squared, right? Then another one is x minus 3 squared plus x squared equals c squared, right? Since there's a right triangle inside, so 5 squared plus a squared equals c squared. Are you able to find x? Are you able to find x? 16, you say, right? Yes. All right, to find x, you just need to look at these 2 equations, right? You can get rid of a and b because the third equation, so equation 2 minus equation 1, okay? You will get x minus 4 squared or x minus 3 squared. Let's see which one first, okay? So these 2 equations, x minus 3 squared, x minus 4 squared, equals c squared minus a squared, which is 5 squared. Then it's done. Okay? So you will get x squared minus 6x plus 9 minus x squared minus 8x plus 16, okay, equals 25. So x squared is gone. You have 2x minus 9 plus 9 minus 6 minus 16 equals 25. Okay, let's get x. Okay, so that is going to be actually 25 minus 9 plus 16. It's going to be, 16 plus 16. So x is going to be 16. So x is 16. Then you solve the problem, right? You can determine the dimension. Yeah, x is 16. All right, my next problem is I have two squares. All right, and what I have here is, this is A prime, B prime, C prime, D prime. Here's A, B, C, D. I put the inside and they're equal, right? So, so what I know is A prime equals B prime equals C prime equals D prime equals half of AB. Okay, so those are the squares. They're all squares. Can you find the ratio of the area of the squares? I don't need to specify the dimension of the square. Okay, find the ratio, the square ABCD over the area of A prime, B prime, C prime, and D prime. Okay. You can assume ABC a unit square. Okay, or you can assume that 2, 2, 2, because it doesn't matter how large of the original square. Just you can enlarge it, right? So, but I assume that just A, okay? Or you make it easier, maybe 2A. Yeah, 2A, 2A, 2A. So if you find if you can find the B, okay? If you well, 2A is, yeah, if you find the B, then express B in terms 2A is fine. So the reason I want to use 2A is because this side I can call the A, right? They're all equal to A. Yeah, A and equal to half of that. So can you find the B? Because this will be 2A squared over B squared. Or you can find it, you can assume that 2B. Yeah, that's enough. Yeah, just 2A. Yeah, that's 2A is fine. So this will be 2A squared over B squared, right? You have to find the A squared over B squared. Right? Find the relationship between A and B. Okay? How do you find the relation between A and B? Okay, let's look at this picture here. Okay, this is 2A, here's A, right? That's a B, right? So clearly, draw these two lines. So we have to draw two lines. Okay, if you draw these two lines, then you will see that it's going to be, this is going to be, all right, any additional information we have here? Okay, it's 45 degrees. Yeah, 45 degrees. Clearly, it's 45 degrees. This is what we figured out, right? Easily. So if you know this, then have this h. You can find the h, because h is going to be a square over 2. Okay, or a is going to square over, a is going to be square over 2 over h. Yeah, we know that because it's this is a 45 degree spatial angle. Okay, so you find the h, right? And then this part will be h, right? So that's why b is going to be 2a plus 2h. Okay, so which is 2a plus 2h. H is going to be a square over 2. Okay, and if you rationalize the denominator, it's going to be 2 square root 2 over 2. So 2 cancelled out. So my answer is 2 plus square root 2 and 8. That's it. So you find the relationship, then you plug them into the ratio. Okay, so that'll be 2a squared over b squared. That'll be 4a squared. B squared is 2 plus square root 2 a squared. So a squared is cancelled out, and you get the answer. Okay. Yeah, that's it. You don't need to simplify it. I think this is good enough. Okay, so let's look at the next problem. So I have a isosceles light triangle. This is a isosceles triangle. Okay, I know that the parameter is going to be 64 centimeters long, and the altitude h is going to be HCM. Find the area of the triangle. Is this the easy problem? Because the parameter, we are not given, I only given the parameter. Okay, not get, you are given the parameter. So you have to find the base. So you can call it A and the B. Okay, you have to find out. You have to find A and the B. Okay, and the area A equals half of B times H. Okay, so can you try this? Once you find the A and the B, you can find H. Right? H is already given. H is 8. Just need to find it. Okay, once you get A, then you get the B. Right? Write down the two equations. Yeah, you have to use, so write down the given information. We are given 2a plus b equals 64, right? You're also given h is going to be 8. Can you determine A and B? But this right? But this H gives you the following information, H square plus half of a B square equals A square, right? Because by the Pythagorean theorem. So now you have two equations in A, B, it can determine the B. Are you able to solve the equation? Yeah, please try to solve the equation. Those are two equations. One is a linear equation, the other one involves squares. All right, so you got two equations, and trying to solve these two equations. Let me write this: 2a plus b equals 64, right? And a square minus half of b square equals also 64, right? Okay. You can use substitution, get you can use a substitution, get an A or B, but you can also, there's another way to do. Use the second equation, you factor it. Okay, but then you realize that A plus B over 2, A plus B over 2 equals 32. So this part is 32. Then there will be much quick way to solve the problem. So 64 over that is actually just 2, right? Because 64 divided by 32 is 2. So now you have two equations, and A plus half of B equals 32. A minus half of B is 2. So add them together. 2A is 34. A is going to be 17. Okay? And if A is 17, then you can get a B. Okay? Yeah. B, half of the B is going to be 19. Yeah. No, sorry, 15. Yeah. So half of B equals A minus 2, so 15. So B is 30. Okay. So you find the B and the A. So once you find the B, then you can get the area. Area is going to be half of the B times H, right? Half of 30, H is 8. Okay. So 120. 120 square centimeters. Okay, so let's go over this problem. You can use a substitution to solve it, but when you see a square minus b square, and then you should affect it. Okay, that you can quickly get a linear equation instead of doing quadratic equation. So this is always a suggestion to do that. Okay, at the end, I'm just want to you do the much simpler problem. It's a isosceles triangle. Okay, and here you are given. So I'll give you a problem here. You know, this is a 8, and that is that's 4. Okay, find the area. So let's finish the class by reviewing the problem. Yeah, this is the isosceles triangle. You're not given the height. You're only given the 3 sides. Okay, find the area. our next class will be relationship between the triangles and the circles. Okay. You should be able to do this type of problems quickly. Can you? Yeah. Find the area. You have two different ways to find the area. So the standard way is using Pythagorean theory to find the height. Okay? So you have to draw the line. You put h there. So what is h, right? By the Pythagorean theory, h is going to be square root of a squared minus 2 squared. Right? Because the other side is 2. Okay, you have to draw addition line. Okay, you have to mark it. It's height, and you have to find the height. Then you see that once you draw the height, then you see two right triangles. So then apply the Pythagorean theory to the right triangle. It's a square of 60. Okay? Square of 60, it has a factor of 4, right? Yeah, 60 divided by 4. 4 times 15. So it's 2 square 15. Okay? Then the area is going to be half of 4 times height. Okay? That's going to be 4 square 15. So this will be the area of the triangle. At least you should be able to do this type of problems, right? After you complete those 2 lessons on Pythagorean theory. But still, it requires you to draw addition line to see the right triangle. So when you get home, okay, review my lecture notes, understand those problems, ideas, then you start to do the homework, okay? Do as many as possible. I know sometimes you have a struggling, but draw the picture first, name the variable, and write down all the possible equations from the Pythagorean theory. You should be able to solve it. If you do not do the problem, and you look at my notes, maybe I already discussed similar problems there, okay?